Hey everybody, welcome to 2.2 deductive reasoning. All right, so we're going to move on from inductive reasoning. Remember, inductive reasoning was you look at data to figure out the pattern that you think is happening. Deductive reasoning is going to be a little bit different. All right, so have you ever noticed that the days are longer in the summer, or that mosquitoes appear after a summer rain? Over the years, you have made conjectures using inductive reasoning based on patterns you have observed. When you make a conjecture, the process of discovery may not always help explain why the conjecture works. You need another kind of reasoning to help answer this question. Deductive reasoning, and this is a good vocabulary term that you should get in your notes. Deductive reasoning is the process of showing that a certain statement follows logically from agreed upon assumptions and proven facts. All right, so before we even get through more of this, what I'm going to do is I'm going to try and make this a little bit more clear because I don't know how clear that is to you right now. So we want to be able to say cars now, so if you look at my example over here, cars blinkers have a stick behind the steering wheel on the left side, right? To make the blinker work, you have to hit that stick down to go left and up to go right. So what we can do is that is the case for every single car. So what you could do is the next time you see a car, go to a car and look to see if that is the case for your specific car, right? So what we have is we have a statement that says all cars have this thing, right? Every single car. Now go ahead and check a specific case, okay? Kind of like if we say for all in algebra, if you add 7 to both sides of an equal sign, right? If I have like 3x minus 7 equals 15, if I add 7 here and add 7 here, we can say that 3x equals 22. Okay, so if we add 7 to both sides of any equation, not just this one, but any equation, we can say the equality, the equal sign, still is true, and then I applied it to just this case. All right, so that is a time where we're applying a agreed upon assumption or proven fact to a specific case. All right, and so that's what deductive reasoning is all about. So I'm going to start here. When you use deductive reasoning, you try to reason in an orderly way to convince yourself or someone else that your conclusion is valid. If your initial statements are true and you give a logical statement, then you have shown that the conclusion is true. For example, in a trial, lawyers use deductive arguments to show how the evidence that they present proves their case. A lawyer might make a very good argument, but first the court must believe that the evidence and accept it as true. So we're going to use deductive reasoning in algebra. You have used deductive reasoning in algebra, and when you provide a reason for each step in the process of solving an equation, you are using deductive reasoning. Here is an example. So here's the example. You can write this down in the notes that I provided or on your own sheet of paper. So solve the equation for x, give a reason for each step in the process. So I see 3 times 2x plus 1 plus 2 times 2x plus 1 plus 7 equals 42 minus 5x. The first thing that I'm going to do is I am going to distribute the 3 and the 2, so that way I can get this to be, 6x plus 3 plus 4x plus 2, and then plus 7 equals 42 minus 5x. And that is distributive property. Right? We know the distributive property. We all agree that it's true, so we can use that process in this specific line. Okay, so the next thing I'm going to do is I'm going to combine my like terms. I'm going to combine the 6x, the 4x right now, and then I'm going to also combine the 3, the 2, and the 7. So I'm going to have 6x plus 4x is 10x, and 3 plus 2 plus 7, well, 3 plus 7 is 10 plus 2 is 12. And we can say that equals minus 5x. I'm going to try and color code this here. And we also get 42. And so why can we do that? We are combining like terms. Right? We're combining like terms. That's the property we can use to do everything that we just did. Okay, so now I would say let's get all the x's on one side. So I would add 5x to both sides. And I get 15x plus 12 equals 42. And what says that we can do that? We can add 5x to both sides, right? That is something we can do. Adding 5x to both sides does not change our inequality. It might change what it looks like, but our equal sign can still stay there. Next, I'm going to subtract 12. Subtract 12, and we end up with 15x equals 30, right? So we subtracted 12 from both sides. All right, and then the last thing we have to do here is divide by 15, and we end up with x equals 2, and so we divided by 15. Okay, so these properties over on the right side over here will always be true. Those are the specific things that we did that we applied to this problem, right? In general, these things on the right side can always be true. So we just applied them to this specific problem. All right, that is deductive reasoning. We're using things that we know to be true and applying them to specific problems, where inductive reasoning is more about looking at these specific cases. What do you notice about a pattern, and then try to make a generalization based on the pattern. They're kind of backwards in some ways. All right, here's our example B. In each diagram, AC bisects the obtuse angle BAD. Classify angle BAD, DAC, and CAB as acute, right, or obtuse. Then complete the conjecture. So I notice that BAD is 120, BAD is 158, and BAD is 92. So angle BAD is obtuse. Okay, if I cut it in half, right, because that's what an angle bisector does, it cuts the angle measure in half. So that means this one is going to be 60 degrees, and so is this one. So that's acute. Okay, 158 divided by 2, 150 divided by 2 is 75, plus 4 more is 79 degrees, and this one is 79 degrees. That's also acute. And then both of these, if that's 92, half of 92 is 46. So this is 46 degrees, 46 degrees. So that means DAC, angle DAC, is acute, and angle CAB is also acute. Okay, so if an obtuse angle is bisected, I'm looking at the conjecture right here. If an obtuse angle is bisected, then the two newly formed congruent angles are, and what I see is every single one is, they are obtuse, right? All three of these examples, the congruent angles are acute. Did I say obtuse? I don't even know. They're less than 90, more than 0, so they are acute angles, all right? So we just use inductive reasoning. That whole thing was inductive reasoning, right? We just looked for a pattern based on some specific examples we have. Now, we want to try and justify this to be true with a deductive argument, all right? So our deductive argument is going to look something like this. I'm going to try and do this for all obtuse angles, right? So our obtuse angles are angles that are between 90 and 180, right? Obtuse angles are more than 90 and less than 180, so they don't include those endpoints. So let's just use these two. Let's use those two endpoints as our angles and see what happens. Okay, so let's say I had a 90-degree angle. Okay, so I have this 90-degree angle, and I want to do an angle bisector. That means this one's 45 and this one's 45. So that's both of those new angles are obtuse, right? I'm sorry, they're both acute, right? Acute angles. If I go 180 degrees, then I would go and I would cut that angle into two congruent parts. That would be, this one is 90 and that one's 90. We have two right angles, right? For a 180-degree angle, and this is our 90-degree angle. So we get acute angles and we get right angles. Now, here's the thing. Our obtuse angle cannot be 180 degrees. It has to be less than 180 degrees, which means the two angles that we create here have to be smaller than right angles. They have to be smaller than right angles. So anything smaller than a right angle has to be acute, right? So we'd say the smallest option, the smallest obtuse angle, will have a bisector that creates an acute angle, and the largest obtuse angle will have a bisector. My handwriting's getting pretty bad here. We'll have a bisector that creates an acute angle. Okay, so if the smallest one creates an acute angle and the largest angle bisector creates an acute angle, that means any other obtuse angle is going to be either equal to one of those two or in between them. So in between acute angle and an acute angle, it's got to be an acute angle. All right, so we went from our conjecture, from our inductive reasoning that said, well, based on these three cases, I think it's going to be acute, to saying that is going to be true for every single obtuse angle that we have, because there's no way to get an obtuse angle or a right angle from bisecting an obtuse angle. All right, so there is deductive reasoning. You are now ready for the investigation.